Okay, students, let's review this activity. The purpose of this, as we get into the evolution unit, we just wanted to start with the question, do we even have any evidence that evolution has occurred? I mean, how sure are we that this is really a thing? And so I wanted to go through just the basic evidence that we have before we delve into the actual mechanisms that you learned about in lab with Hardy-Weinberg. Okay, and so to do this, we kind of just set up two ways of thinking about it, whether evolution is real or a literal creationist theory. So I want to be clear, I'm not talking about the creation that we believe in as Latter-day Saints. More, I'm talking about like the literal creationist theory that the earth is less than 10,000 years old, that everything was created exactly as it is today. Okay, and that's just a way of introducing the evidence, but really let's just go through and look at the evidence. One of the evidences we have is what we call homology, right? And so that's the idea that there's a lot of similarities between creatures that come from our evolutionary history, that we're related. So if you look at a human's arm, you look at a bat's arm, you look at a flipper of a whale, because we're all mammals, we all have the same humerus, radius, thumb, metacarpals, and I think Neil Shubin calls it the one bone, two bones, a bunch of little bones hypothesis. Okay, so homology is a good evidence of our evolutionary relatedness. Okay, that's opposed to analogy. So a lot of times we see similarities like between a shark and a dolphin. We see these similarities that are due to a common environment, not because they're really closely related, right? So that the ancestors of a dolphin were like four-legged creatures running around on land, whereas the ancestors of a shark are fish, fish-like creatures. Okay, so that's convergent evolution. Another part of the evidence is what we call the law of superposition, and that's just that the deeper rock layers we assume are older than the less deep rock layers, and as a consequence we can look at fossils that are found in deeper rock layers and say that they are necessarily older than fossils that are found in upper rock layers. Let's see, another one is the fact that we have all these fossils of transition species and ancestral species. These are just two examples. Archaeopteryx is a famous one because it's the ancestor of modern day birds. It's a dinosaur and it had feathers. And then Homo ergaster is one of the ancestors on our family tree. And so the fact that we have fossils is good evidence that evolution has occurred. Another good evidence that we're all related is that we all use the same genetic code, right? So you can take a gene from a bacteria, put it in a fish, put it in a human, it'll be transcribed or translated exactly the same. There's a few exceptions, mostly in bacteria and mitochondria. And then we talked about, vestigial structures. So vestiges are another example. These are structures that are left over that everybody has, but they don't appear to have much of a function. Like a tailbone, right? We still have a tailbone, but we don't have a tail anymore. Or the little muscle that's underneath your skin that makes your hair stand up, or our appendix. These are all leftovers from our evolutionary history. Now let's contrast that with atavisms. Atavisms are also throwbacks to our evolutionary history, but these are things that not everybody has. Not everybody expresses them. So we might have had a gene at one point, or we did have a gene at one point that gave us the nipple line all the way down our abdomens as a mammal. But over time, something happened in our regulation that shut that off. Excuse me. And so you can get, a single mutation that could turn that gene back on. So it's evidence that those genes are there, they just aren't always expressed. So an atavism is one that you usually don't express, but shows our evolutionary history, whereas a vestige is one that everybody expresses that shows our evolutionary history. Embryonic development, you can see that most organisms look exactly the same as they develop as an embryo. You can see that the dolphin, for instance, had some feet, right? We have a tail and gill slits. And so this is just evidence of our common relatedness. And then the last one was just how old is the Earth? And the Earth turns out that it's over 4 billion years old, 4.6 billion years-ish, give or take. And that the first life forms actually came about 3.6 billion years ago. So life is really old on our planet. So there's a lot of evidence that evolution occurred. So we're going to spend the next several weeks talking about the little mechanisms by which evolution occurs. So how does it occur? And then we'll talk more about some of these macroevolutionary events like hominid evolution. All right, so that's it for this activity.